Welcome again. So here is another problem that is testing on application of the gamma function. So it's to evaluate these improper integrals and then to give the answers in the exact form by application of the gamma function techniques. So let's see how we are supposed to solve this. Now, the first problem is to evaluate the integral from 0 to infinity of y power 3 e raised power minus y dy. Now, remember that from definition, gamma of y is given by the integral from 0 to infinity of t raised power y minus 1 e raised power minus y minus t, and then dt. So this is the definition of the gamma of y. And we also say that gamma of y is the same thing as saying y minus 1 factorial. So these are the formula that we gave at the start of the session. So these are the definition, and then we are making use of this fact. So with that in mind, we are going to transform our integral to take the general structure of the gamma function and therefore define the gamma, define the integral in terms of the gamma function. So if you relate these two, we see that the limits agree. Also, the limits are agreeing, and also what we have here, we can write this as integral 0 to infinity of y power 3 e raised power minus y dy is the same as integral 0 to infinity. I can write this one as y 3 can be written as 4 minus 1 e raised power minus y dy. You see, these variables y and t are dummy, but the structure of this integral here is exactly the same as the structure of the integral in the definition of the gamma function. This and this are the same, only that the role of y is t. T is the same as y, and y in this general form is the same as this number 4. So this is simply the definition of gamma of 4. So this number here. And gamma of 4 is the same as 4 minus 1 factorial. 4 minus 1 is the same as 3, and 3 factorial is the same as 6. So therefore, the answer to this integral is just 6. If that didn't make sense, now concentrate on this second part. So second part of the problem is to evaluate the integral from 0 to infinity of y power 6 e raised power minus y dy. So we can write this one as integral from 0 to infinity. Y power 6 is the same as 7 minus 1 e raised power minus y, and then dy. Now, if you check the structure of this new integral, the way we have redefined the integral, rewritten the integral, is simply the definition of gamma of 7. So gamma of 7 is the same as 7 minus 1 factorial. So which is the same as 6 factorial. And 6 factorial, when you work it out, you get 720. So the key rules or properties of the gamma function that we are using are gamma of x is the same as x minus 1 factorial, and gamma of x from definition is the integral from 0 to infinity of t raised power x minus 1 e raised power minus t and then dt. So those are just the two facts that you are using to simplify these improper integrals. Number 3 of that problem was to evaluate the integral from 0 to infinity of y power 9 e raised power minus y dy. So also what you do, you rewrite this one as integral from 0 to infinity. Now 9 can be written as 10 minus 1 e raised power negative y dy. Reason I'm writing 9 as 10 minus 1 is to ensure that I have the structure of the general definition of the gamma function, so that then I can use the two properties we have stated in the previous problem. So this is exactly the definition of gamma of 10, and which is the same as 10 minus 1 factorial, which is the same as 9 factorial. And when you work out this one, you get 9 factorial is the same as 362,880. So that's the exact value of the improper integral given in 3. And then part 4, we have to evaluate the integral from 0 to infinity of y power 3 e raised power negative 4y and then dy. Now in this particular problem, you really have to be careful. It is not as direct as the previous ones, whereby we're just rewriting the powers of y as n minus 1 and then say this is a gamma function. Remember that gamma of x is given by integral from 0 to infinity t raised power x t raised power x minus 1 e raised power minus t then dt. But you see, if you write this as 0 to infinity y raised power 4 minus 1 e raised power minus 4y dy, this is not the same as gamma of 4. So take care of that. That's not true because of this power. We expect this power. If for this to be gamma 4, then we expect the integral to be of the form 0 to infinity y raised power 4 minus 1, then e raised power minus y dy. This is what gives gamma 4. But when this is the way the power is, then this is not true. So therefore, we have to do some transformation to ensure that this power of exponential is simply negative of just a single variable. So we'll say, let us take 4y to be a value, say u. So let u to be 4y. So we want now to change from being an integral in terms of y to the new variable u. So this means that du is the same as 4 dy, which means dy is the same as du over 4. And then once we have that one, also we have y alone will be given by u divided by 4. So we'll now rewrite the integral of y power 3 e raised to power minus 4y dy. So this limits from 0 to infinity. Now, I remember when you are doing the transformation, also you have to ensure that you take care of the limits. Now, limits. So when y is 0, remember these are limits for y. Then we have u will be equals to 4 times 0. So u will also be 0. So this means y equals to 0 implies u is also equals to 0. Now, when y is infinity or approaches infinity, then u will be given by 4 infinity, and 4 times infinity is also infinity. So therefore, y equals to infinity also implies u is infinity. So limits are unchanged. Now, when the limits are unchanged, then we have 0 to infinity. Where there's y, we put u over 4, and then u raised to power 3, e raised power negative. So therefore y is the same as u, and then dy is the same as du over 4. So then we'll have, remember this will be the integral 0 to infinity. Now these are quarter, then we have 4 quarters here. So we'll have 1 over 4 power 4, and then u power 3, and then e raised power minus u, and then du. So this 1 over 4 raised power 1 over 4, when you raise to power 4, you get 1 over 256. Integral from 0 to infinity, u raised power 3, e raised power negative u, and then du. So you see, if we rewrite this one as integral from 0 to infinity, u raised power 4 minus 1, e raised power minus u du, it will give us a structure of the gamma function, and it will make our computations easier in terms of the factorials. So this will say the same as 1 over 256 integral of u raised power 4 minus 1 e raised power minus u du. So which will be given by 1 over 256, and then this is the definition of gamma of 4. Now this is the same as 1 over 256 times gamma of 4 is the same as 4 minus 1 factorial. So 4 minus 1 is the same as 3. So 3 factorial divided by 256, which is the same as 6 over 256. And that will give us 3 over 128. So therefore, this is the answer to that given problem. Now, the next part, we are supposed to evaluate the integral from 0 to infinity of y power 3 e raised power negative 7y dy. We'll do the same transformation. So we'll say let u to be given by 7y. So which means du is 7 dy, which means dy is the same as du over 7. Now, once we have now the expression for dy, y alone from this one, I will be given by u over 7. And then limits, you also have to determine how the limits are changing. When y is 0, u will be given by 7 times 0, so which is 0. So lower limit do not change. And then when y is infinity, u will be given by 7 times infinity, which is also infinity. So limits do not change. Now, therefore, we'll write this one as integral 0 to infinity, where this y we put u over 7 raised power 3, e raised power negative u, because 7y is u, and then where there's dy we put the u over 7. Now, this is also the same as 1 over 7 power 4. Power 4 because we have power 3 here and then power 1 here. Integral 0 to infinity u power 3 e raised power minus u du. Now, 1 over 7, when we raise to power 4, we get 1 over 2401 integral 0 to infinity. Now, 3 can be written as 4 minus 1 e raised power minus u du. So this will give us 1 over 2401. This is the definition of gamma of 4, which is the same as 1 over 2401 times 4 minus 1 factorial, which is the same as 3 factorial over 2401, which will give us 3 factorial is 6 over 2401. So that will be the answer to that given problem. Now, the next problem, or the last part of that question, was integral from 0 to infinity of 2y power 4 e raised power 1 minus y dy. So we're just going to do transformations or rewrite the integrand so that it takes the structure of the gamma function and convert gamma functions into factorials to be able to find the solution. So this can be written as, I can factor out 2, and I write integral from 0 to infinity y power 4 e raised power 1 and then e raised power minus y dy. These are simply the laws of indices by rewriting this e raised power 1 minus y. E raised power 1 is just a constant, so can also be pulled out. So we'll have 2e integral from 0 to infinity y power 4 e raised power negative y dy. Now we write this one as 2e integral from 0 to infinity. This 4 can be written as 5 minus 1. So we write y 5 minus 1 e raised power negative y dy. And you see, by doing that, then this integral is simply giving us the structure of gamma of 5. So this is the same as 2e gamma of 5. And by definition, gamma of 5 is the same as 5 minus 1 factorial, which is the same as 2e times 4 factorial. And 4 factorial is given by 24. So I'll have 2e times 24, which will give us 48e. So this is the exact value of the integral. Remember, if you now put this one as a decimal using calculator, it will not be exact. When you write the exponential just in this form is what gives the exact value. If you put it now as a decimal, then you'll be going against the instructions of the problem of giving your answer in exact form. So that's how we solve that problem, and let's also meet in the next session to do more examples on application of gamma functions. Thank you.